Right, well, after that unexpected amateur radio thing we did with the AC290, we're back to a CB radio. I know this is supposed to be a CB radio channel, but just sometimes, you know, we've got jobs on which people might be interested in. I know some of the viewers out there are interested in anything we do, whatever the product is. So we've got here a rather nice looking Fidelity 2001. Now this hasn't been switched on for more than 20 years, the customer says. So he doesn't want me to switch it on without going through the capacitors, as he's had experience with things which have killed the product by switching them on without addressing capacitor issues. So yes, that's a sensible thing to do. So we'll do a few of those capacitors which are in a vulnerable area. What we don't want to do is to destroy the audio IC. So I think we'll do the ones around the audio IC. I think we'll do the main one on the power supply, and then we'll take it from there, because most of the other circuits are 5 volts or 8 volts. I can soon monitor on the power supply whether it's drawing more current than I'm expecting. So the Fidelity 2001 uses the Cybernet PTBM002F chassis, which is that used by the genuine Amstrad and the Harvard 420M, and it handily says green and yellow on the speaker. I wonder if that's correct. Got the correct ballast resistor in, and you know what, that doesn't look played with, does it? It's had something done on the back there, but I think that's factory done on the back. So I better switch the soldering on and get straight on into it. And what we will do is, I will, as soon as I've changed enough capacitors to be able to switch it on, I think we will go through it like I normally do and just see how it's performing before we do any service work. It seems a sensible thing to do, but it looks in great condition. So I think the sensible thing to do here is to change that and that. That's in a hot area, and it ends up with the transmit there. That, and those two. Yeah, I think that 1, 2, 3, 4, 5, 6, 7, 8, and we'll leave these smaller ones to see what happens. So I'll set about doing this. I'll probably see you in 20 minutes. Okay, well, go back into record. I've actually changed every capacitor, or there's 16 of them in these radios, and I thought, well, you know, wanting them changing is necessary. Most of them are only about 16 to 24 pence. You know what? Oh no, I was going to say, I've missed that one. That's one I've missed. We'll come back to that one later. And they're all Nichicon ones of the highest quality. Yeah, we'll come back to that. No, we'll do it now. When I've done the radio, we'll go over it with isopropyl alcohol and clean all the flux off. I noticed the lid, the front's broken there, so it's had its bashing about at some time in its life. So it's positive to the right, and it's 4.7 microfarads. Normally Mr. Trippy does these kind of things, but I wanted to get the set out of the way, and it will delay it a few days because he has his own job in tray, and these don't prioritise over his in tray. It's nice to see the factory original microphone. So it's 17, 4.7 at 35 volt. Right. Now this hasn't been switched on for a couple of decades, so this is going to be interesting. I think we'll connect our instrument speaker up. I like it when people buy new old stock stuff from the 1970s, well, you know, like a hi-fi amplifier or something, and then expect it to work just because it's brand new in the box. Well, the good news is it won't. Right, power on. 13.6 volts today. Switch on. Last used on channel 22. So channel 9 off, dim, bright, RF gain to full, mic gain to full, scroll to a sensible place, and let's go through it. So switch picture in picture on, and we'll actually select the right camera. So TX. He says he thinks the mic's iffy, but he'll get a mate to look at that. Okay, it's gone straight across to 2.8 watts. And we'll now put the camera on the frequency display. So it's 27,79108. So it's drifted a bit low, as they do with age. So we can do that right now. And this is one that's gone up there fine. Don't know what's wrong with my One Heart Cat's pen. It's undoing itself. Okay, let's just check deviation. I was last doing those amateur sets, wasn't I? So my meter's in the wrong position. And there's the door. Okay, so that's taken in the parcel from Hermes, which was one of those rugby controlled clocks, radio controlled clocks, for my elderly customer, church friend, whatever. I see the retired nurse. Well, she was a nursing sister. She wanted one of those radio controlled clocks, so at least she knows what time it is all the time. So the microphone the customer has sent, which he thought was Duff, is Duff. So there's no audio on it. So he's going to get a mate to look at that. That's fine. So I've put our standard replacement on. Wallow, and it's got about 1.5 deviation. So TX deviation 1.5 kilohertz. Now these are either one end or the other, aren't they, when you see them? They've either been screwdrivered to 7, or they're, as they've left the factory, at a paltry 5. So let's get that set. We'll bring that up a bit. Let's try it there. Wallow. Whoa, that's over the top. Let's try it there. Wallow. Testing 1, 2. That's spot on. Good. Right, so that's done. That's looked at that. Let's look at receive, just for the record. We're not going through everything at this point. They need to bring that from 144. I'm expecting an RS delivery, so that doorbell's going to go again. Right, so let's see what we've got. So put the SINAD meter on. That's alright. So, as presented, 0.24 microvolts for 12 dB SINAD. Well, I don't think we're going to get much better than that. So, we will of course look at the squelch. So now I'm going to start on the tune-up. And I'll no doubt have to get the service manual out because I've got a memory like a sieve. So we have to remember that it's a floating chassis. Put the multimeter on. Find out where my negative lead is. Far end of capacitor 12, I think it is, or 23 or something or other. Why are we over range? Oh, because we've got the hold thing on. Okay, let's get the manual. This is so important every time you see anything with this chassis, because they will go out of kilter at the top of a hat, and you end up with channels dropping out. So we need to select channel 1. There we are, channel 1. So we start off on receive, and we want 2 volts between capacitor 9 and so we want 2 volts. There's capacitor 9. It's 2.3. You can end up with these so out of kilter you end up with a minus voltage. That'll do. So going to transmit, and it's supposed to be CT1 for 2 volts. So CT1, now we'll go back to receive. It's still got 2 volts. Now we'll go to channel 40, and we're supposed to have, but it never is, around 4.5 volts, and on transmit we've got 3.3. Take no notice, it's set right and it's in lock. Now we'll go on the real tune-up. So at the moment we've actually, it's 2.5 watts as we've warmed it up. So we'll just maximise these. Oh, we'll make sure we're on channel 20 because I'm good at that. So no change there. No change there. I may end up changing the ballast resistor at this rate. Also known as a dropper resistor, quite correctly. Back in the 1920s and 30s, dropper resistors were called Berettas. That's after the hat on a priest's head. So that's what they look like. 2.5 watts. So that's now well over the 3. Change scales. I'm going to change the ballast resistor for exactly the same type, but one that'll actually handle more than 3 watts. I don't know why they put a 3 watt resistor in. And there's the door. Okay, so battery cord, that was the RS delivery. Now we're just waiting for some building materials. So we've changed that for a 6 watt resistor, and put the power supply back on. Let's see what the difference is with power now. Not a lot, but it's 3.5 watts. So we'll just go through that again. So if I take this radio up to 14.4 volts, which is where a lot of cars charge, so now at 14.4 volts, it is doing 4 watts. If we took this down to 12, like you've got it on a caravan battery that's about to go flat, the radio's doing just under 3 watts, which is about where we started off today. So I'll leave it at that. I could start changing the values to get 4 watts on 13.8 volts, but I don't see any need to do that because these are different watts than you're likely to see on a CB test meter. If I put the Zitagi meter on, it's probably doing 7. These are the watts that the government inspectors would be going by. So that has done all of transmit. We're going to just do the meter, and we'll just check low power as well, just for a laugh. So let's see if we can see the meter. Boing, it's saying 4.5. Let's take that down so that it says 4. So we've got the adjustment there. That now says 4. So when it was doing 3, it was probably quite generous. So we'll just pop that to low power, and let's look at what low power is on this radio. It's 220 milliwatts. There's no adjustment, and of course we could start playing with resistor values, but there's no need to do that. So we've got great transmit, and what else was I going to check? Oh yeah, we've done the meter, we've done low power. We weren't. We're going to see if there's anything we can do with the receiver, which is absolutely lovely, because we didn't know what it was like before we changed the capacitors, and we daren't switch it on without changing the capacitors in view of what the customer had said. So we'll start with the detector, and I usually forget which one it is, and although I've got the manual in front of me, is it that one down there or is it that one up there? I'll tell you what, let's look for once. T11. And T11's that one, so I'd have gone for that one. So we're going to put an S9 equivalent signal on the signal generator, and we're going to look at the oscilloscope. Turn the bench light off so it's a bit more visible, and we're just going to set this for maximum recovered audio. The oscilloscope's just simply across the audio output to the extension speaker. Wow, that was considerably out, so that will make a huge difference. Okay, now we'll go back to the SINAD meter. Put that to about 5 decibels and go through the front end. I'm not expecting any improvement. probably fix it worse. Just put a bit more signal onto these IF ones. I don't know if any of you have been watching Danny, who rate my takeaway from, it seems to be from Leeds in Yorkshire, because I'm from Yorkshare, and he pulls up at some random takeaway and gets his folding picnic table out of the car and tests the takeaway, and you know, you think this is all very genuine, you know, real bloke and that. Well, I've just ordered one of those picnic tables, so that when we do Radio Ham Field Day, we can get that out of the van, but it won't be to set my dinner out on, it'll be to set some radios out on. So I wouldn't have known which one to get until I saw Danny rating his takeaways, so well done, Danny. It's well worth watching if you haven't subscribed to him. He's a real laugh, and without swearing. So, well, that seems to be what I can get out of it, and I bet you it's now worse than before I started. Let's have a look. So there we are at 12 dB. We started off at 0.24 microvolts. Well, it's now 0.24 microvolts. Okay, I'll just show you the control showing that. So we've got this small one at 0.3, and we've got the little one there at, there's 2.5, 2.4. So now we're going to set the S meter. So we're going to put S9. May as well save electricity and turn the oscilloscope off. The S9 equivalent signal, which is 100 microvolts for a CB in the UK. And it's a bit generous, that, so we'll just pop it down. I'm sure it's that one there. It's probably going to be the wrong one. No, it's the right one. So that's now S9. And finally, the squelch. Now this is the letdown on these sets. So I want it to do 100 microvolts before the squelch. Well, I want it to open at S9. So what we're going to do is turn the squelch to full. And that's, of course, the radio is now muted. And now we're going to turn the attenuator 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts, exactly where I want it to be. So on this occasion, perhaps changing the capacitors has magicked it into the right position, but because this is why I wanted to do these extra ones, you know, in this part of the circuit. So that's spot on. Had we needed to adjust the squelch, it's the preset there. RV5, I think I can see on the circuit. So now we're going to do the opposite. We're going to put the signal generator to standby at 0.3 of a microvolt. I'm going to turn the squelch right down, set it to threshold, switch the signal generator on. Hey, it's come straight in. So it's coming in. God, I think we've got the best ever here. It's coming in at 0.21 of a microvolt, and it's disappearing off at 0.06 of a microvolt. Wow. Well, I think he's got the best performing Fidelity 2001 there is. We'll just go back to what that power says on this meter. I really can't be bothered to go and get the Zetagi meter. It's in another room. And I've proved this so many times before about real watts off this instrument to not so real watts coming off the Zetagi test meter. We've got a Bremi one here, which is even more wildly inaccurate. So let's just key it up for a fraction of a second. I don't know what my power supply is doing, but I want it at 13.8 for this. There we go. 3.6. Right. So I'll put that together. Now, out of interest, and it doesn't matter at all, is the green the chassis, or is the yellow the chassis? Yeah, green is chassis. You just never know what colour wire they've used. So in this case it's green to the left. We've had a lot of Duff speakers recently. We used to have this in the business radio thing with customers who had Kenwood two-way radios. I know they do amateur radio equipment, but they do business radio equipment as well. And the speakers were hopelessly inadequate for business use, to be quite honest. You know, you put that in a diesel taxi and the driver can't hear it, even with an extension speaker. So you end up with burnt out speakers on the internal one. So we had a lot of that, and we're having a lot of that at the moment with CB radios. So before I put this together, I'm going to cover this with do this with isopropyl alcohol, and just get where's Mr. Chippy's toothbrush? Where's the proper brush? Where's anything? Ah, there's the proper brush. You know, these are £5.95 plus VAT each from RS. Oh, of course you have to buy a pack of 5. When I was at Nottingham Radio, the owner, John, came round to each of the 3 benches. He says, right, I've got you an RS brush, and you're only going to get one. And if you lose it, you'll be buying another. I didn't like that down there, so we'll clear that. So I'm going to leave it 20 minutes. I know it's a warm day. I've only taken the room air conditioning off to do this video. I do try and keep the room we do the CBs at a constant temperature of somewhere around 72, 22 Fahrenheit, something like 22 centigrade, something like that. Well, I think that will do. It's a very nice radio, that. Right, so I'm back with you half an hour later. That should have dried. I'll put the lids on. And those building materials arrived. Right, so just check that we've still got transmit. We have, and I'll just show you that now. I'm going to turn the other camera off, and then we'll put it on the aerial and see what rubbish is out there. So there's 5 watts, so that's 4 watts, and it's doing a full 4 watts even on this set. Now it's cooled down, and we know that when it's really hot and it's been transmitting a long time, it's doing 3.6 watts. So we're back on its own aerial. Switch the test set off. Farmers tend to use that channel around here, and along with channel 9 for some bizarre reason. 19 Roger. Isn't it lovely living in the middle of nowhere where there's no music playing going on channel 19? Anyway, we'll do an on-the-air test later, and that's a really nice radio. What have I been doing taking the aerial out? I must be losing the plot. Thanks for watching the Fidelity 2001 from 1981.